Hey, good afternoon, everyone. I've been thinking about following up on yesterday's class, and I wanted to talk about two particular things. The first, so I recognize that many of us solved those problems yesterday by starting with the standard um, sine function and modifying the parameters to fit the context, which is a fantastic strategy. I want to talk about another strategy um, that I'll just attribute to how we tackled the Ferris wheel problem. Remember, we began with building the function from the context. And maybe just to remind you, we picked a point on the Ferris wheel, i.e. on the circle, and built a formula to figure out the y coordinate in essence. I'm going to go through that process for problem one, just to sort of re-emphasize how we might use that strategy. And then I'm going to build a second video that I think I'm going to use problem 5, the spring, and just go back to the parameters and talk about modifying those, especially just to, instead of, in many cases, especially for the horizontal shifts, both the dilation and translation, there is some playing around to get there. So I want to try to emphasize how we can actually compute those values as opposed to estimating, guessing, and checking. So that's my goal with these two videos. This first one, I'm going to focus on problem 1. Give me a moment. I'm going to share a whiteboard and just talk as I work through the problem. That will be my goal. Okay. This is the problem, as you might remember, of a pebble on a wheel. I'm going to start thinking about the pebble being on this tire, which I'm representing with a circle, and then I'm going to lay a coordinate axis onto the circle so I can think with my circular trig functions that I know. Having done a little thinking about this problem, I recognize, I'm going to jump, by the way, to I think the question of how high off the ground is it after you have traveled 15 inches, because this gives me a chance to just like work through a problem, and maybe from working through the problem, I'll be able to generalize a process and a formula. So 15, from working on this problem, I know that the circumference of the tire is 24 pi, which is approximately 75, just for thinking. So 1/5 of the way around from the bottom would be maybe at about right there. So I'm going to go ahead and just label a point, call this my XY point where the pebble is. So with that, let me start naming some things I know. So I know this value of R, and I think I can figure out this angle right here, which I'll call A for now. So I know angle A is some portion of a full turn, and that ratio of angle A to the full turn has got to be the same as the distance, the arc length in essence that I just traveled in relation to the full circumference. So the ratio of the angles is the same as the ratio of the arc lengths. We saw this very similarly when we did the, I forget the name of the task, but it was above the fence, that above the fence task, right? So I can solve this for A, and I'm going to skip a couple steps if you want to pause and just make sure you get the same thing. I get A is 225 over pi, which is approximately 71.62 degrees. And that makes sense. It's a little bit less than 90 as I predicted. However, okay, so good. However, for working with trig functions, we know we have to use the standard rotation. What I just called the standard rotation, I mean from the horizontal, the positive x-axis rotating counterclockwise, right? So if I know A is 71.62 degrees, this angle that I'll call B is just got to be 270 minus A. Again, I'll just do the quick math, and instead of writing as a pretty horrible fraction, I'm just going to keep thinking in terms of decimals and degrees. By the way, I'm more comfortable working in degrees rather than radians. Either way, would be perfectly fine. So instead of 360 right here, I could have written 2 pi. Holy smokes, I'm just looking at that for the first time and realizing that would make A15. Wait, I have to think about that. I'm not gonna pause during this this video. So I guess let me go back to say we have this pebble at some location x comma y with the rotation b degrees. And I think we all remember that. The sine of theta defined in circular trig is just the y coordinate over the radius. So I know all these things. I know the angle, I know the radius, and I don't know the y. So I can figure out this y value. It is the radius, which is 12, times the sine of my sort of not friendly angle, 198.38 degrees. Notice this y value is this height right here, right? So that suggests that my height off the ground is the center of the wheel, or the center line of the wheel, which would be 12, minus y. However, I'm actually just going to go ahead and write plus y, because 12 sine 198.38 degrees is a negative number. Our circular trig spits out a negative value for y, as it should. Take a look at the sketch. I think that would be apparent. So just sort of to check myself on all of this, I got a value of 8.22 inches. That seems reasonable to me. It's lower than 12, above the halfway line. All that seems above 6. So all that seems to make sense. So with all this, I'm going to try to generalize, and I'm going to try to make some big steps to generalizing my process. By the way, look what I just did. I figured out the height of the pebble at a specific moment when the distance traveled had been 15. And I need to find the height for any generalized distance. So instead of 15, I'm going to use the letter D. So to generalize, I'm going to take a few leaps of faith and then just check to see that it makes sense. It seems like my height, take a look at that height structure. I'm going to erase and start fresh here. I'm going to say the height is 12 plus 12 sine of some angle. And the question is, how did I get that angle? Well, remember that angle was determined by, that angle was angle B, wasn't it? The angle was 270 minus A. And A, how did I figure out A? I figured out A based on the 15. So A was 15, which I'm going to replace with my distance, times 360 divided by I see what I did wrong here. This should be 24 pi. I knew when I was looking up there a moment ago, something was incorrect. Sorry about making that mistake earlier. Gosh. So D times 360 divided by 24 pi, which simplifies to 15 over pi times D. So going back down here, I have 270 minus 15 over pi times D. So it looks like I might have my function. H of D is 12 plus 12 times the sine of 270 minus 15 over pi times D. That should be it. Maybe a very last comment I will make today is I noticed many of you ended up with something a little different right in here. a couple things are happening possibly. So first of all, you've seen that sine functions repeat themselves over and over and over again, right? So my shift of 270 minus this might be the exact same as this plus 90 degrees. Well, it would be actually the same as that plus 90 degrees, I believe. So this might look a little different based on how far your horizontal translation was. I shifted it in one direction and maybe you shifted it in another direction. And then another thing might just be how you factored out maybe the number times the d. So anyway, let's back all the way up. You can see how I built this sine function from the context. And that was one of the strategies I'd like you to be comfortable with. So I hope listening through that was helpful. I'm going to make a second video. Take a look for that one for problem 5.